Welcome to part 2 of module 1 or chapter 1. We have a few more definitions to get through. Our first one is quantitative data. Consists of numbers representing counts or measurements. So quantity, you can see the word in there, has to do with the amount of something. The other one is sometimes called qualitative, but we're going to use a different word. We're going to use the word categorical. Data. Consists of names or labels that are not numbers representing counts or measurements. So this is the other type of data where it's more of a significance than it is a number. Practice a little bit. So we're going to label this either as categorical or quantitative. The ages of survey respondents. Well, that's definitely having to do with numbers. So that is definitely going to be quantitative. The political party affiliations, so Democrat, Republican, and so on. That is definitely categorical. You can't really put a number on that. Now, we could artificially do that and put them in alphabetical order or something like that and then count them or something, but that's artificial. Next up, an alphabetized list of synagogues in a certain county. That is still going to be categorical. And there's really no numbers attached to that. Blood pressure readings from a group of cancer survivors. That is definitely quantitative. And we got a couple more definitions. Chapter 1 and 2, a lot of definitions. So next up, we have discrete data. As the result when the number of possible values is either a finite number or a countable number. Versus continuous data. Result from an infinitely many possible values that correspond to some continuous scale that covers a range of values without gaps or jumps. Discrete is going to be things that can literally be counted. So just kind of keep that in mind that it's countable. That's the key word with discrete. Next two words, and by the way, these two have to do with quantitative data, these two here. Versus the next two. First, we have nominal. Nominal data result when numbers have no value and the order of the list is irrelevant. So I kind of touched on this just a little bit earlier, where we have a list, but the order is completely irrelevant. That's versus ordinal data. This is where the order does matter. And both of these have to do with the categorical. And we have this nifty chart here for you. So we have our data, and it's either quantitative or it's categorical or qualitative. And then the quantitative gets broken up into either discrete or continuous. And the categorical gets broken up into the nominal or ordinal. Ordinal, again, is that the order does matter. So let's try classifying a few things. All right, so our first one is religious affiliation. There is no order to that, and there's no number really to assign to that. So that is going to be nominal. I'm just going to put an N there. The number of goldfish in a pond, that is definitely countable. That is definitely discrete. The weight of goldfish, that is continuous, actually. Now, that's a little weird for us because when we think of weight, we think of I weigh 150 pounds, I weigh 160 pounds. In reality, no one weighs exactly the same, right? Maybe I'm 145.7396 and so on, right? So there's actually no gaps in between when it comes to weight. meaning the difference between 100 pounds and the difference between 101 pounds, there's actually an infinite number of weights in between those two. There is no gap. Next up is nationality. Nationality is definitely nominal. The age of the oldest child, that one is going to be continuous. Now, again, we think of our ages in discrete terms. So when I say that I'm 48 years old, I'm not exactly 48 years old. I'm 48 years old, so many months, so many days, so many minutes, so many seconds, and so on. And you can see there's even time in between each second, right? In fact, there's an infinite number of time between 1 second and 2 seconds. So that's why we consider that continuous. Now, zip code is an interesting one because that involves numbers, but the numbers don't have significance. So this is actually a nominal category. One zip code isn't somehow better because it has a higher number or something like that. So even though numbers are involved, this is still nominal. The order is irrelevant. Water temperature, that is continuous, has to do with numbers. And again, between 1 degree and 2 degrees, there's actually an infinite number of degrees in between, 1.1, 1.111, 1.11112, and so on. Height, this is nominal. It's not nominal, it's continuous, pardon me. Continuous. And jersey number, here's another one where we have numbers involved, but the numbers themselves are irrelevant. If my jersey number is 7 and someone else's is 12, that doesn't mean one's better than the other or has any categories like that at all. So this one, again, is nominal. Now, I'm noticing we didn't have any that were ordinal. We will get to that a little bit later. Moving on to the next page. So we're going to assign a level of measurement to each variable. So we have just a few more definitions here. Our first one is ratio. So this is a level of measurement where there is a natural zero starting point and the ratios are meaningful. For example, if I said that someone makes twice the amount of money that I do, that the 2 is a ratio, and that is meaningful, meaning someone literally makes double what I do. And there's a natural zero, right? I make $0. Can't go any lower than that. Next up, we have interval. Is a level of measurement, have differences that are meaningful, but there's no natural zero starting point. So a good one is like temperature when we're talking about Fahrenheit or Celsius. Kelvin would be ratio, actually. Next up, so here's our ordinal again. There's a level of measurement where the data can be arranged in an order, but the differences can't really be found. They're kind of meaningless. And I have some examples there, and we'll do some more examples here in a second. And the last one, again, is nominal. Is a level of measurement that are categories only. So data can't be arranged in an order. So let's do some practice with that. Sweatshirt sizes for small, medium, and large. Now you'll notice that the order matters. So in this case, this is ordinal. Nationality. Now, there is no order for nationality. So this is nominal. Salary, as I mentioned before, salary has a natural zero, and someone can make double what someone else can make, or half, or a third. So this is definitely ratio. Year of birth. This can get a little confusing. This is actually interval, because the years that we have assigned to our various years, for example, this video is being made in 2021, there really is not a natural zero. There's no zero, because time existed before zero, the BCE and so on. So there really is no natural zero. And you wouldn't say that a tree that was 1000 AD and then a tree that's 2000 AD is twice as old or something like that. It just doesn't quite work that way. So we say interval. Volume of water used. That is going to be ratio, because the volume could be 0. And I could have twice the amount of water that you have. And that 2 is significant. It has meaning. Year in high school. That is meaning we have an order: freshman, sophomore, junior, senior. That is with an order, so that's ordinal. Dog breed, and I don't want to start a fight or anything, but that's definitely nominal. Age of a student. Now, age of a student is ratio because the age of a student could be 0. I guess the person's just born. And then you have someone who's twice as old as someone else. You could have a 10-year-old, you could have a 20-year-old, and the 20-year-old is twice the age of the 10-year-old. So those ratios do matter. Water temperature, that's definitely interval. When we're talking about degrees in Fahrenheit, which in real life, that's how we normally address that. Height of an oak tree, that is, again, ratio. When it is first coming out of the ground, it has 0 height. When it's 10 feet tall, and then later when it's 20 feet tall, it's twice the size that it was when it was 10 feet tall. I hope that clears things up a little bit.